In this lesson, we'll continue our review of Math Test 10, Section 4. We're still in the early to mid part of this section, so the questions aren't too difficult, and problem 13 and 14, we have a paired set, and so we have given information, we have two questions relating to it. Sometimes you might even see three, and typically the first question is easier than the remaining. All right, so let's take a look at the graph. We have this histogram, these bar charts, and we've got different colonies, A, B, and C. On the y-axis, number of insects. On the x, weeks after initial treatment. All right, and so let's just read. 3 colonies of insects were each treated with a different pesticide over an 8-week period to test the effectiveness of the 3 pesticides. Colonies A, B, and C were treated with pesticides A, B, and C respectively. Each pesticide was applied every 2 weeks to one of the 3 colonies over an 8-week period. The bar graph above shows the insect counts for each of the 3 colonies, 0, 2, 4, 6, and 8 weeks after the initial treatment. So question 13, the first problem. Which of the following colonies showed a decrease in size every 2 weeks after the initial treatment? And then we have choices, so there could be a combination of more than one. So let's take a look. All we're looking for, this is an easy question, is a decrease every 2 weeks starting from the beginning. And if you look at colony A here, started at 80 and then went down again, still down and down. So definitely A, it went down every 2 weeks. And colony B, it's here, went down, down a little bit. Yes, so B works as well. And C, we see right away from here, this went way up after the 2 weeks. So it's just A and B for this one. So let's take a look. It is 1 and 2. C. And then one more question relating to this information, number 14, of the following, which is the closest to the ratio of the total number of insects in all 3 colonies in week 8 to the total number of insects at the time of the initial treatment. So just be careful reading. You want to solve for what the question is asking for. We want the ratio of all the insects, all the colonies in week 8. So the first part of the ratio, we're just going to estimate based on the bar chart for each one of these. So colony A, it's really close to 20, so I'm just going to call it 20. And then colony B, we're going to call it 10. It's right between 10 and 20. And C is between 40 and 60. We'll call it 50. So that is 80. So that's the first part of the ratio. And then now we want the total number of all insects at the initial treatment. So that's before the treatment started. That's right here at the beginning. So colony A, it is 80. Colony B is 70. And colony C, it's about 55, right? It's not in the middle. We'll call it 55. So that's 150. That's 205. Okay. And you could use your calculator for this one. It looks like 2 to 5. Here, it's calculator pins. Let's just use our calculator. You could also reduce this, but it's just a little bit easier. We'll just plug it in. So it's about 40%. It's 2 to 5 here. Yeah. 2 to 5 is 40%. So you could also just, I would just make it 8 over 20 and then just divide it by 4 to get 2 to 5. All right, last question on this page, number 15. A right circular cone has a volume of 24 pi cubic inches. If the height of the cone is 2 inches, what's the radius in inches of the base of the cone? So this is one of those formulas you really just have to know it. I know it's given at the beginning of this section, but I'm not even going to scroll back. You just should know the volume of a cone. So the volume of a cylinder is pi r squared height. It's the area of the base, which is a circle, pi r squared times height. But this is a cone. So if they tell you it's a cone, it's just like the volume of a cylinder, but it's 1/3. That's the only difference. So just remember that. Again, it's given at the beginning, but it'll save you time. So they also tell us the height is 2. So I'm just going to put a 2 in there. And the first thing I'm going to do is divide both sides by 2 and pi. We have a 2 and a pi on both sides. So here I'm going to change the colors to make it a little bit easier. So we're going to divide 2 pi by both sides. Okay, and so here was our 2, and here was our pi, and sorry, this is, sorry, it's 1/3 r squared equals 12. All right, I just divided by 2 pi. And then I'm going to multiply both sides by 3 to get rid of the third, so I get r squared equals 36, and then square root, so the square root of 36 is 6, b.